In this video, we're going to trace through the execution of a tail recursive version of Factorial. The Factorial function has one parameter in, which is the number we're computing the factorial of, and it returns an integer that is the factorial of that input. The difference between this version and the previous implementation is the helper function named factHelper, which has two parameters, an integer in and an integer answer. In is the number we are computing the factorial of, and answer is a running product that gets computed with each recursive call. You can see that when factHelper calls itself, it is the last computation it does. This is called tail recursion. Let's step through the execution. We begin inside of Factorial, where in has the value of 3, and we're going to call factHelper. So we need to create a stack frame, and we're going to send in the arguments, in equal to 3 and answer equal to 1. We mark the call site location with a 1, so we know where to return when we leave the function. Inside of factHelper, because in has the value of 3, we skip over the base case, and we're going to call factHelper once again. This time, creating a stack frame for the next recursive call, where in has the value of 2 and answer has the value of 3. Now, as we step through this code, note that it does not have a compiler optimization that we'll introduce later in this video. So this is going through the tail recursive function as you would expect it to happen, with nothing fancy or optimized yet. We step into the function, once again we pass the base case, then we make another frame for the next call to factHelper, where in has the value of 1 and answer has the value of 6. We step into that function, pass the base case, and make another stack frame for this call to factHelper, where in has the value of 0 and answer has the value of 6. This time when we step into the function, in is less than or equal to 0. This is the base case, so we return the answer 6 all the way up these calls. Returning from the recursive call to call site location 2, then repeatedly returning to call site 2 and destroying the stack frame for each recursive call. This repeats again. Finally, we return the value 6 to call site location 1 and move our execution arrow back into the function factorial. Now the thing to notice here is that we only needed to return the value 6 all the way up these calls. As soon as we placed each tail recursive call, we didn't actually need the stack frame anymore because there's no value in the frame that we're going to use again. An optimizing compiler will recognize this and perform what's called tail recursion elimination. A stack frame will not be created for each recursive call to factHelper. Let's step through the optimized version. We start inside of Factorial once again with in having the value of 3. We create a stack frame for factHelper where in has the value of 3 and answer has the value of 1. We mark the call site location 1 and step into factHelper. In is not less than or equal to 0, so we're going to place the recursive call to factHelper. However, we're going to reuse the frame. First, we have to evaluate the parameters to 2 and 3 respectively. Note that we do this before we start changing any of the values in the frame, since we want to use the current values. Then we are going to update the value of in the frame to be 2, and the value of answer to be 3. Now we jump back inside of factHelper, past the base case, and once again we're about to place a recursive call. But instead, the compiler will make the code update the values of in and answer to the new arguments 1 and 6. We skip the base case and reuse the stack frame one more time, this time with in having the value of 0 and answer having the value of 6. This time we go into the base case and now return the answer of 6 one time back to call site location 1 in the function factorial. Notice that the stack frame does not need to be created for every call to factHelper. What this means is that the space you require is no longer proportional to the size of in. You simply need one frame for factorial and one frame for factHelper.